Hey guys, it's Eddie the Magic Monk. In the next few lessons, we're going to show you guys how to differentiate exponential functions, and I'm going to make sure that I demonstrate the reasoning with a graphics calculator so that you can see the reasoning behind what you're doing instead of just doing it blindly. So let's have a look at the exponential function y equals e to the power of x. If we draw this on a graphics calculator, it'll look a little bit like this. So in GeoGebra, if I type y equals e to the power of x, it'll look like this. So why does it look like that? Because the number e, if you just type y equals e is actually equal to 2.72. Okay, so just like the number pi, e is also a different number with some important meaning behind it. If you want to know more about why e is equal to 2.72, that's another video. But we're going to focus on how to differentiate it. So y is equal to 2.72. You could rewrite it if you want to the power of x, but that would defeat the purpose of e, because e is basically a number that keeps going forever. It's not just 2.72. Okay, it's 2.719 blah 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 and so on. So we're going to go back to the graphics calculator. So you can see y is equal to e to the power of x. So when x is equal to 1, when x is equal to 1, we can see this point right here. When x is equal to 1, y is equal to 2.272, right? Why is that? Because in our equation, if I set the x value to 1, what does y equal? Y equals e to the power of 1, which is 2.72 to the power of 1, which is 2.72. So similarly, when x is equal to 0, y is equal to e to the power of 0, which is 2.72 to the power of 0, which is 1. Anything to the power of 0 is equal to 1. So you can think of some random number, 4351. If you raise this number to the power of 0, it gives you 1. Okay, so let's try another number. When x is 2, y is equal to e to the power of 2, which is 2.72 to the power of 2. If you type that into your calculator, you get 7.398 and so on. So let's now test that out in our graphics calculator. So if I go to, let's make this, let's zoom out a bit and let's just type in x to the power of 2. And you can see where the black line intersects with our green line. Okay, let's just make the axis a bit smaller so you can see it. When x is equal to 2, y is equal to 7.39. So yes, it's proven our table of values. Okay, so let's talk about how to differentiate it. So if I get rid of some of this stuff, differentiating means to find the gradient function. Find the gradient function. So what is the gradient function? The gradient function basically tells you the gradient at any point on this line. So how do you find the gradient? Well, if I draw a tangent line on this curve. So let's draw a point first and make sure your point is touching the line. Oops, just brought all this stuff back for no reason. If I draw a point on this line and then I draw a tangent line, so click this, click tangents. If I draw a tangent line at this point, then the equation of the tangent line tells you the gradient of the line of the black line as well as the gradient of the green line. Okay, because whatever the gradient of the black line is at that point, is the gradient of the green line at that point. How steep the green line is. Now, if we move the black line to a certain spot, just any spot, it'll work. And let's have a look at the y value on the green line. So vertically where this point is positioned. Compare that to the gradient of the tangent, which is the number in front of x. You will see that they are equal. This is 2.78, this is 2.78. Does not matter where you move it. If I move it over here, 1.9, 1.9. So what does that mean? That means that at each of these points, so y is equal to 1, the gradient, which we call y dash, is also equal to 1. The gradient is equal to 2.72. The gradient is equal to 7.398. So at each of these points, the gradient at that point is equal to the y value at that point. Okay, these two numbers are all equal. Gradient is equal to the y value. So what we can say is now y dash is also equal to e to the power of x. So if someone says differentiate y equals e to the power of x, differentiate y equals e to the power of x, you simply write y dash is also equal to e to the power of x. How easy is that? Okay, now let's make it slightly harder. We're going to say differentiate y is equal to 3e to the power of x. So we put a number in front. So guess what happens? Well, if you use the calculator to have a look, if you put a number in front of e to the power of x, let's say we put a number 2. Have a look at the y value of the green line and compare that to the gradient of the tangent line. It is still the same. Okay, 9.16, 9.16. Drag it somewhere else, 3.22, 3.22. So when we differentiate it, we can again just copy the constant. The constant still exists in the derivative, right? Because the derivative, the gradient, is still the same as the y value. So whenever there's a constant, just copy it down. Can't get any easier. Okay, so the third possibility, which is slightly harder, is what if I want to differentiate e to the power of, let's say, 5x. So the power has changed. So let's test that out with our graphics calculator. And let's change the equation from e to the power of x to e to the power of, actually, I probably should start with 2. So I'm just going to change it to 2 because 5 is probably too big to show you guys. E to the power of 2x, and let's show you that here. So let's now have a look at, let's compare the number of the y value to the gradient of the black line. So you can see that whatever the y value of the green line is, we multiply it by 2 to get the gradient of the black line. Right? You always multiply this number by 2 to get this number. So y dash is equal to 2 times the y value. Okay, but how would we know that without drawing the graph? So I'm also going to show you the chain rule. So let's have a look at this rule, which is a short version of the chain rule. There is a longer version that we don't need to know right now. So the chain rule basically says when there is a function which is g of x inside another function which is f of x, how would we differentiate that? How do we differentiate a composite function within a function? what you would do is you differentiate the outside function, which is f of this. We differentiate that, and then we multiply that by the derivative of the g function. So how do we do that? Well, let's apply it. So let's say we want to differentiate y equals e to the power of, let's say, 3x squared. Make it slightly harder for you. So we basically need to recognize that y is made up of two functions. The first function is e to the power of a number. This is a function. So let's pretend that 3x squared is just a single variable. So when you differentiate, when we only care about the outside, you just simply write the derivative of the e function, which is the same. So we've taken care of this part here. We've done that. Now let's take care of this part. So we multiply by the inner function, which is 3x squared. So we now want to differentiate just the power bit. So what's 3x squared differentiated? Bring the power to the front, minus 1 where the power is, so it's 6x. So y dash is equal to 6x times e to the power of 3x squared. Okay, so let's test that out. Okay, let's test that out to make sure we're right. So let's get rid of all of that. Let's change our equation to y equals 3 times x to the power of 2. Oh, look at what the graph has turned into. How crazy is that? Okay, so now let's find the gradient. Let's draw a tangent line on this curve. Draw a gotta define a point first. Define a point. Draw a tangent line. Draw a tangent line on this point so we can drag it around. Okay, so let's just set the x value to a particular point. So let's set the x value to let's make it a whole number. So when x is equal to 1, it's almost vertical. How crazy is that? When x is equal to 1, y is 20.41. So let's try that. When x is equal to 1, y is equal to e to the power of 3 times 1 squared, which is e to the power of 3, which is 20.09, 2dp, 2 decimal places. And now let's substitute 1 into the gradient function. So 6 times 1 times e to the power of 3 times 1 squared. And let's type that in. And the gradient is 120.513. And if we have a look at our GeoGebra, what is the gradient? 122.8. Now the reason that it's doing that is because we're not really sure if x is actually on 1 right now. Okay, because when you drag it, you just have to be really careful. So we are going to draw a line called x is equal to 1. Is that what we want? Yeah, x is equal to 1. And we're going to move this point to the intersection between those two lines. Okay, so we're going to move it right here, just to make sure we are on it. And you can see here that it says when x is 1, y is 20.09, and the gradient is 120.51. So it's exactly the same. Okay, so let's just do another quick example. Let's do differentiate y is equal to e to the power of 5x cubed, and that's question 1. Question 2, differentiate y is equal to 6e 3x 4. 3x to the power 4. Okay, try these two questions and come back when you are done. Okay, so now I have y dash equals differentiate the inside, differentiate the outside, which is just basically copying it all out, and then differentiate the inside, which is 3 times 5 is 15x minus 1 where the power is, so it's 15x squared. So let's write that out, 15x squared e to the power of 5x cubed. Okay, and then let's do the second one. So y dash is equal to, differentiate the outside, which is 6e 3x to the power of 4. Differentiate the inside, which is 4 times 3 is 12x to the power of 4 minus 1 is 3. So the answer is 72 e to the power of, 72x cubed e to the power of 3x to the power of 4. Okay, thanks for watching, guys. See you next time.